For the same reason that we consider 2 over 4 an unreduced answer, we also consider answers that have radicals in the denominator unreduced as well. You would never leave this answer on a quiz or a test. You would always reduce that to 1 over 2. Same thing would happen if we get the square root of 3 over 2. We're going to do what's called rationalizing the denominator in this video, and that deals with getting rid of the square root in the bottom of fractions. So we're not allowed to have something like 5 over root 2 in an answer. We consider that an unreduced way of writing it. So let's talk about how we do that. So if I've got something like the square root of 3 over 2, we can start by splitting this up into the square root of 3 over the square root of 2. These two are the exact same thing. So writing a big radical and writing the square root at the top over the square root of the bottom is the same thing. The next thing I need to do is find a way to eliminate this square root in the bottom, this radical 2. And to do that, I'm really just going to multiply by something that won't change the original expression. So I'm going to have to multiply by 1 in some sort of funky way. So the key is with this is whatever, when you're dealing with square roots, that is, when you're dealing with square roots, whatever's on the bottom, you want to multiply by on the top and the bottom. So effectively what I'm multiplying by is 1 because I have the same thing on the top and bottom. So I'm not changing what this is equal to. So now when we do that, so if I look down here I had a root 2, so I decided, okay, I'm going to match that with root 2 over root 2. When I do that now, what's going to happen is we're going to get on the top the square root of 6 and on the bottom the square root of 4. And what you're going to notice is something kind of magical happened. The square root of 4 is a perfect square, and that can just be written as 2. So on the top of this fraction, I have the square root of 6 still left up there, and now the radical is out of the denominator. So this answer is simplified. It's done. We rationalize the denominator. And another friendly thing to remember if you watch the video on multiplying radicals, you cannot combine something outside of the radical with something inside the radical. We treat this as like someone who's in prison, and the bottom here is someone who's not in prison. Okay? You can't just have someone who's in prison walk outside and talk to someone who's not in prison. So we can't reduce this. This is not equal to the square root of 3. That is incorrect. What it's actually equal to is 1/2 the square root of 6, or the square root of 6 divided by 2. All right, let's jump to the next one. So same rules apply. We're going to look at the bottom here, and I see a square root of 2. So I'm going to start by multiplying by the square root of 2 over the square root of 2. Whatever's down here on the bottom, we need to match on the top and the bottom. When we do that, on the bottom, we're going to get a square root of 4. That's a perfect square. That's good. And on the top, this is going to be 2 root 2. Remember that I cannot multiply numbers that are under the radical times numbers that are out of the radical. So it's really just 2 times 1 root 2. So 2 root 2. Now, on the bottom, the square root of 4 is just 2. And on the top, we're still left with 2 root 2. We actually can go a little bit further because we can simplify now. We have 2 over 2, which just reduces to 1. So this answer could just be written as the square root of 2. Okay, so this would simplify to the square root of 2. And if you punch this in your calculator and you punch this in your calculator down here, they're going to be exactly equal. We're not changing the value of these numbers, we're just writing them in a more reduced fashion. Okay, now number 3, you can take this the long way, and the long way would be this. You could multiply by the square root of 4x squared over the square root of 4x squared, and then you could try to reduce the radical, take out perfect squares and all those good things, and cancel anything on the top and the bottom. But this one's going to be a little bit easier because this is already a perfect square. So if we look at the bottom, if we split this up into the square root of 3 over the square root of 4x squared, you'll notice that the whole bottom is a perfect square. So the square root of 4x squared we can just reduce to 2x, and on the top we're left with the square root of 3. And that is as simplified as we can get there. Again, I encourage you to try it the other way too. You should have a matching answer here for both of these. All right, we got 3 more to go. We're going to look at the square root of 7 over the square root of 8. And again, hopefully you're getting the pattern here. We're trying to get the radical out of the bottom. So we're going to multiply by the square root of 8 over the square root of 8. On the bottom, that's going to give me the square root of 64 over the square root of 56. And now again, if we kind of look at what we can simplify on the bottom, 64 is going to simplify to 8. So our square root of 56 will simplify to the square root of 4 times the square root of 14. Again, notice that I am taking out perfect squares where I can. So there is a perfect square here. If you remember our list, we said 1 squared is 1, 2 squared is 4. So we can take the square root of 4 out and make this a 2 root 14 over 8. And 2 over 8 will reduce to 1/4. So this is just the square root of 14 over 4. So we can reduce this fraction right here to 1/4. And I could put the 1 out front of the 14, but it's not really necessary. And then this would be our final answer here. Okay, I also encourage you, there's another way you could do this, where you could take out the 4 in 8 at the beginning and then just multiply by the root 2 that would be left on the bottom. It's an alternate way to do this. It would still work both ways. Okay, now that we're here, we're going to look at the square root of 5x over the square root of 2y. So again, sometimes we have variables in here. When that happens, I'll just multiply by same sort of pattern, root 2y over root 2y, and that's going to give me the square root of 10xy, no perfect squares up there, over the square root of 4y squared. And what you might start noticing here is that this part is always just going to simplify to what we had originally under the radical up here. We're just canceling the radical out and we're left with this again when we take the square root. If that shortcut confuses you, don't use it. Take the extra step to figure it out. And then again, no perfect squares come out of 10 or those x's or the y's here, so that's as simplified as we get. Now the last one. You can also reduce the inside of these fractions at first if possible. So I could multiply, there's nothing wrong with this, I'll have an extra step here. I could multiply by root 3x over root 3x that way, but I'm going to try to make my life a little bit simpler by reducing this radical here first. So 6 over 3 reduces to 2 over 1, so this whole thing's just going to reduce to root 2 over x. And now instead of having to multiply by that 3 and taking out perfect squares, which you'll see if you do it the other way, all I have to multiply by is root 2 over root 2. Oh, sorry, I lied. Root x over root x. My fault. Let me fix that. So root x over root x. And then when I do that, I'm going to have the square root of 2x over the square root of x squared. And notice that my radical is gone from the bottom. So the key with these problems is you want to get rid of the square root on the bottom. Square roots on the bottom are considered unreduced. When we have that square root on the bottom, we have to multiply by whatever's under the radical on the bottom, on the top and bottom, and then just simplify the fraction and any perfect squares that can be taken out, and you are good to go. So there is more you can do with this when you have something called the conjugate. I won't get into this in Algebra 1, but if you take an Algebra 2 class, you may talk about that, where you're going to multiply by something that's not just the square root of 2 over square root of 2. I may make a later video on that for Algebra 1 or Algebra 2, but for today, this is good for Algebra 1 and the keystones.